Welcome everyone to another episode of Adventures in DevOps, and it feels like I haven't been here in forever. If you don't know who I am, I'm Will Button. I am the co-host here, and joining me in the studio today is Jonathan Hall.
Hey everybody, how's it going?
Good. And then we have our guest today, Mike Wagner. How are you, Mike?
I'm doing awesome. Thanks, Will.
Right on.
Hello, Jonathan.
Well, it's great to have you here because today we're going to be talking about some bare metal stuff, right?
Oh, I thought it was heavy metal. I thought we were doing all rock and roll today.
We can do a little of both. I always like, yeah.
Oh, my bad. I thought bare metal was like a subgenre of heavy metal. You know, because you have like death metal and emo metal and goth metal. I thought bare metal was another. Okay.
Is that where you play guitar naked?
I think it is. I'm sure that there's a Substack dedicated to it.
And for everyone who's
there was a Reddit
on
group,
YouTube,
but it's on strike right now.
A community, a Substack, a YouTube channel. I'm sure we just scratched the surface of something amazing.
So what is bare metal? I mean, we've all at least been involved in some way, but it's something that's not forefront of our minds these days. What is it?
Yeah, so a bare metal server is just a server that you generally run a single instance on. So it's a dedicated server. Okay, so whoever is and it's different things depending on what level you're approaching it. But from an infrastructure and operations perspective, we like working with enterprise architects, VPs of IT, the guys that are responsible for creating the clouds, the private clouds, the hybrid clouds, whatever it may be. So across the board, we work with all of the big OEM players. So it's Dell, HP, Supermicro, Lenovo, Cisco. And, you know, whenever you talk about, you know, what's the cloud or what is the edge, you know, the answer is truly it's just someone else's computer, right? That fabulous meme that's been around for a while now. So somebody has to work with those servers. Somebody has to keep the BIOS up to date. Somebody has to keep the firmware of all the peripherals where they need them. And it was kind of a neglected segment, this whole idea of low-level operations and working with bare metal, working with servers. So yeah, that's, I guess, in a long-winded way, bare metal is just someone else's server.
That's what I thought the cloud was.
Yeah. Well, the cloud's based on bare metal.
The cloud is made of metal. Wow.
Yeah.
Some dense atmosphere here.
Isn't that amazing? And now, of course, they're reselling that as, you know, bare metal as a service, right? So you can actually get your servers just the way you want them, sort of custom metal, if you will. And wow, the premium on that is really amazing to witness. So what we recognized, my CTO and I and co-founder Ian Evans, years ago, we recognized that there was this almost everyone sort of getting drunk on public cloud and virtualization, and there's an efficiency gap, there's an architectural problem with it, and then there's also security and all sorts of other concerns kind of that we recognize that, you know, if we could find a way to make it easy to do DIY bare metal, so you could build your own clouds easily, you know, almost public cloud-like ease. And on your last episode, I enjoyed the GCP versus AWS discussion. And I must say, I fall in the GCP camp as well. I seem to have kicked tires on AWS multiple times and just paid for something that didn't really lead to a lot. But GCP has always worked fairly efficiently. So it's the idea. The idea was to make something so simple, you know, just to create a UI that made it incredibly easy to discover, provision, and maintain your servers across multiple platforms. So any hardware provider, any hardware manufacturer, through a single pane of glass.
Right on. So there was a thing came out by the guy who did Ruby on Rails DHH. I can't remember what the DHH stands for, but anyway, he was talking about moving his company from the cloud to bare metal and the savings that they were forecasting to save that. And I think in his particular case, we talked about that on one of our previous episodes. It makes sense. Is that the people that you're trying to target there as individuals who are trying to reduce their spend and gain more control over their environment?
Yeah, so that's certainly so cloud repatriation is the buzzword
Oh,
of
that's
the
a
day for
nice
that.
term. I like
Isn't that
that.
nice? There's a lot of repatriating going on lately, and we're working on most parts of it. Um, being the patriots that we are, because we actually are love America. Have traveled a fair amount, and man, the United States is awesome, but it's another story. Um, so, cloud repatriation in particular, um, yes, there's organizations that you reach a certain point in your cloud spend where you can save a lot of money by bringing it in house. There's a lot of factors related to that. So, having the right skills, having the right tools in place, those are all really critical to make it happen. And we make that ridiculously simple. So yes, we've done repatriation projects, and the results are always awesome. I mean, so far everything has worked out very well, I should say, because I'm sure there's large projects out there and enterprises that could tell horror stories. But as long as you have the right tools in place and you don't try and bite off too much at once, it's similar to cloud migrations, really, right? And then everybody shoved stuff up into the cloud, and they realized when they got the bill that maybe this was dangerous.
Right.
Then of course there's always the problem of um, shadow IT, right? With everyone popping up AWS or GCP instances, and nobody being able to really track what's out there. So um, yeah, no, it's we definitely do some cloud repatriation. We do a fair amount of white space where it's just okay. We have a new project. We know we want to do it in house, and a lot of hybrid as well. And then the edge stuff. That's the thing that really played in our favor was just the expansion of the architecture and of where compute is being placed now because of the ever shrinking platforms you can put tremendous compute on. Um, so Moore's law and the really fun march of technology getting smaller and faster and just more amazing. And being a tech geek, it's just a blast to get to work with these small form factors. And so we've done some really cool stuff with the DoD related to that, and some ISPs as well. Some edge, I guess I shouldn't call them, some edge compute players overall. So yeah, it's the space is exciting. There's a lot happening in it, and being able to provide a platform that can make that easy has always been our overall vision.
Right on. Whenever it comes to actual physical location of these servers, do you have the space that you provide, or do you work with people with their existing spaces, or what's that part look like?
Yeah, so we have we have both. So we work with a number of, excuse me, um, hosters, colos, data centers that we can partner with. And that's the other thing, right? We're almost exclusively a channel led company. So we work with partners across the board. So SIs that do OpenShift implementations, um, SIs that may have a managed service practice or, have a colo facility or colo partner. We work with colos directly. Um, so yeah, a little bit of all of it, and
Okay.
depending on what the customer wants. That's the big thing. One of the big things that we recognize also back when we were sort of alpha testing the product in our prior lives before we launched as a startup was that the customers, especially the Fortune 1000 set, they've been in place for a long time usually, and they have very particular tools that they like using. They have particular architectures that they like. We wanted to give them the freedom to choose and stay on whatever they were working with. We would provide guidance, and you really are largely preference free because depending on the use case, it's definitely each implementation is its own sort of beautiful snowflake. It is what it is, and a lot of the enterprises have done excellent work establishing the practices that they have in place, and this just we let them keep the choices that they want, and then we come in with this low level platform that makes handling the metal itself incredibly simple. So,
Right
So
on. Yeah, I
a little
think
bit
that
of
makes a lot of
little bit of all of
sense.
the above. Hmm.
Yeah, because like whenever you think about bare metal versus cloud, in the cloud you choose from whatever product that cloud provider is offering you. But in bare metal, it's like, hey, here's a CPU, some compute, some memory, go for it.
Yeah, yeah, absolutely. And now custom chips and GPUs and this your Chat GPT episode was really cool. Um, I mean, just all the things that are happening on the edge or wherever with ChatGPT 4 and the other AI players, the demands around what we're trying to do from a compute perspective have just gone through the moon. So, now it's a matter of, okay, where can you get access to these advanced chipsets? And where can you get access to the bare metal to do the crunching that you want it to do? So it's a really fun space to be in right now.
What are some of the biggest differences when you're dealing with bare metal from your standpoint, not from the customer standpoint?
Mhm.
Because I imagine you try to make as much of that transparent to the customer as possible. They get the advantages without the extra toil of dealing. They're not physically installing hard drives and running
Mhm.
cables. From your perspective, though, managing this stuff, what are the differences between selling bare metal services and if you were just selling traditional cloud services?
Okay, yeah. So we don't personally sell it as a service, if you will,
Mm-hmm.
but I what we've seen from an implementation perspective with regards to how we handle um, different hardware footprints. That's sort of its own beast for us, right? What we do wasn't possible uh, 5 years ago because the standards weren't there. So these low-level hardware standards just have really become ubiquitous in the last 2 to 3 years. And in particular, the folks at the DMTF have done a great job. The Distributed Management Task Force that came out with the Redfish specification. So we'll get geeky for a second here, and these are the low-level guys that have put the open project in place that essentially everyone has gotten behind that, or OpenBMC, which is part of the Open Compute project. Um, and between those two, as well as a few other open standards that are out there and driving change, like SNIA has Swordfish, um, and there's a Yang to Redfish model as well. There's a number of open standard projects that are going on that are all sort of working as one now, if you will, with sort of
Mm-hmm.
Redfish as the um, almost underlying base foundation of an open API to write towards. Um, Things have really progressed for us. So how we work with other with each OEM, that's kind of part of our secret sauce for sure. And not everyone adheres to the Redfish specification perfectly, which has always kind of been one of the problems with open standards. Um,
What?
you know,
Oh my God.
yeah, imagine.
I thought only
So
Microsoft had that problem.
yeah, no, especially the guys in the cellular space. Wow, are there war stories about that from an open standards perspective? But we've done a fair amount in sort of the access network space and the RAN space. They love their acronyms more than any other, the telco guys. Yeah, I mean, the open standards debacles that went on there were just, and still are just kind of wild and crazy to witness. But finally, on the data center side, things have really, really come along in the last couple of years. So all the manufacturers now of the motherboards are on board. So all of the servers that go out, essentially will have a BMC that adheres to one of the other specifications or both. Yeah, you can have at it, and with some tweaking, with some customizations, you can create that single environment to work on any server from anywhere. So that's really the cool thing. As long as there's a plug going into that server and a network connection of some type, we can do it's true out of band lights out management, right? So it's that uptick in service that you normally had to pay a lot for if you wanted to do it in a proprietary way, and then you'd have to learn each proprietary tool, and we got rid of all that. Just one tool to rule them all, if you will.
Wow, that's crazy. It's been a long time since I've dealt with bare metal, and to be honest, I haven't missed it, but it sounds like it's come really a long way in terms of being able to do that out of band management and get the visibility of what's actually going on at the hardware level. And so this is a service that you provide is you take the hardware and you integrate all of that so that the customer has that visibility remotely to the physical hardware.
Yeah, yeah. It's a down. So we're a software tool, right? Kind of viewed as, an out of band utility platform. Okay, so and you can download it, and check it out for 30 days, um, and then immediately start discovering your assets. So that's the other big piece. It does a discovery, and then we've got a service catalog that's built in, and you can provision whatever OS you want. You can go upstack with that and provision an OpenShift cluster, or an Anthos cluster or Rancher cluster. We work with all of them. Um, so it's a powerful tool, and with great power comes great responsibility. So we take security very seriously, and we've air gapped multiple networks on the internally within the product to make sure it's safe, and adheres to some NIST and DoD certifications. So there's across the board we kind of wanted to make this enterprise ready, and address the big concerns that we knew our enterprise customers had, going into this project, whenever they want to take on a bare metal um, project. There's the number of things that Ian and I both had a lot of years working in data center environments, and he especially had to fix a lot of issues and architect and design things from the ground up. So he took all that experience and kind of you know uh, put it all into sort of the dream INO product, the dream low-level utility to make life easier for data center operators.
So I'm going to possibly show my ignorance here. If not, it'll become evident by the end of the episode. Um, is is SNMP still like a thing? You mentioned the auto discovery and the service discovery of the hardware, and I remember
Mhm.
long ago using SNMP to try and accomplish that. Is that still the pattern?
Yeah, well, SNMP is still out there. I think, and this is something that Ian could answer much better than me, but the key now is we're all RESTful. So we switched to REST, and that's where obviously the industry, right? API and API for everything sort of idea,
Mhm.
and the SNMP as a protocol certainly is still out there, and I'm not sure how often we interact with it, because the availability of all of the pieces that we need are essentially there via REST and via a standardized API, the Redfish
Oh
specification,
wow.
the Redfish API. So it's a big shift in how the underlying infrastructure can be discovered and worked with.
Right on.
The big modern shift. Yeah.
Yeah, for sure. And I hadn't really thought about this problem in the past, but there was a ton of opportunity there waiting just in that level of abstraction. So yeah, I can see the thought process and why you would tackle this problem and the potential improvements you can make on it.
Yeah, it was really cool. It's one of those when we showed it to customers initially, when we show it to them now, but even back, when we were alphaing it, the response was consistent. It's like, okay, cool, let's get it into our lab. We like it, we'll buy it. There was no product, and the bit of guidance that we got was we want it to be, we want no sort of proprietary pieces in it at all. We just want it to be not beholden to any particular software stack or hardware provider. We just want it based on open. So that really required us to launch it as a startup. But as you're saying, you can picture it how it's helpful. As soon as we showed it to these VPs of IT, these enterprise architects, they're like, "Oh my God, okay, okay, you did it. I had this idea." So we got to hear a lot of sort of anecdotal stuff about how They wish this was in place. If this was only there when I was at eBay, you know, yeah, some tons of stories, right?
Oh yeah.
And yeah, the crazy part about it's just somebody else's computer is it has become so um, simple to just fire up an instance, but at scale, the bills are insane. And then with the power of compute today, the cost savings as well as the security considerations, AWS has been handing over a lot of information that companies didn't want handed over. So there's security specific security profiles that we work with that as well as sort of that's the best way to put it. So high value targets, if you will. So we have some
Hmm.
folks that are well known and they want to make sure their stuff is secure. So another use case for having private cloud is just knowing that it can't be turned over to via subpoena without your approval, right? So yeah, there's really interesting, just tons of use cases out there um, that bring a need for this sort of immediately recognizable. And yeah, the guys, when they see it, they're just like, "Oh God, there it is, finally." So
Yeah, for sure. I think that's a lesson a lot of companies are in the last couple of years are learning the hard way that the cloud providers and in addition to that, SaaS providers were very convenient to onboard, but they're also very willing and ready to turn over your data to anyone who asks for it.
yeah, yeah. Well, it's another revenue stream. I mean, it's
Oh, for
stunning,
sure.
right? It's yeah. If you don't check the paperwork carefully, watch what you sign up for. Click through contracts are, whew, you just never know. Um, so yeah, no, that's a great point. We're in a wild and a data. We're in the data wild west, if you will. Anything they can grab, they will.
What's a typical onboarding or implementation for your software look like? What's the barrier to entry?
Yeah, it's very low barrier to entry. We're about to send out our latest release will allow for single click download and installation. So we're really excited about that. We're probably 3 weeks away from getting that out. Um, so it's really simple. You can download it, and then we can walk you through sort of a white glove installation process to make sure everything's working right, and that's done in a couple hours. Or we have an appliance as well, and we have a few customers that just said, "Cool, build us an appliance and ship it out." So we've got, and you can pick the form factor on that as well. So we've got palm tops, we've got two use, single use, whatever sort of the use case calls for. We're as flexible as our customers need us to be, because given the locations, the points of presence of some of these sort of compute environments, um, it can be, you know, uh, something that we need to be weigh about a pound and fit in the palm of your hand versus a 2U pretty heavy horsepower couple of servers. So so yeah, it's but overall the software itself is very easy to download and to load. And we're, like I said, just a couple weeks away from making it a single button go.
Right
Um,
on. So that should be about the time this episode releases. What's your website?
nice. Yeah, it's www.metify.io.
So I'm curious, what types of clients? I don't want you to tell us names unless
Mhm.
you have agreements that allow you to do that. But like, what kinds of clients and what kinds of workloads is this ideal for? Like, and the second part of the question is, who should not do this?
Hmm. Um, so yeah, it's a fun one for us because well, okay, so a number of our customers we have obviously NDAs in place with, and they don't, like us. They feel there's a competitive advantage related to
Sure.
how and who and where and all that good stuff. They are implementing Mojo as part of their architecture. Having said that, Major League Baseball published a really cool article as well as in their technology blog about how they use Mojo Platform to power all of the baseball stadiums in North America. So as far as use cases go, this is kind of the perfect hybrid edge use case that has GPU dependencies and hybrid in that 7.2 terabytes of data per game are then uploaded into GCP. And it's a Anthos, push button Anthos implementation. So yeah, this is, what from a use case perspective, we did not think Major League Baseball was going to be, we didn't envision them as a customer, but it makes sense, right? And when you're as low level as we are, it's almost like asking Intel, what's your perfect customer, Well, it's pretty much anyone that does compute at scale and has the need to, access these servers and make sure that the BIOS is up to date. Make sure that any zero-day vulnerabilities can be taken care of without having to fly in and do a thumb drive shuffle, or as Kevin Backman from Major League Baseball calls it, the hand jam. And that's just travel and maintenance expenses on servers, because it is what underlies private clouds, public clouds. It's a significant budget hit. So yeah, which is another reason why public cloud is as popular as it is, because okay, well, you don't have to worry about that, right? Well, similarly with this, it takes away the concern of having to fly somebody in and update the BIOS or update a firmware, and remotely monitor exactly the health of that system, or even create a snapshot and then make sure from a governance perspective that there's no configuration drift on that server versus the rest of the servers in the field. So we've got customers with thousands of servers, and with configuration drift, something can happen, right? The guys in the labs push out an update, and it's possible that if they're not exactly aware of the BIOS levels and what chipsets are in those servers, that it could cause something to go down. And bricking a subnet, bricking a major portion of a company's intranet is a bad thing. So yeah, we make that a lot more governable and transparent to the guys that need to know that information.
That's crazy. I hadn't even thought about that use case, but like baseball stadiums, where they have a huge compute infrastructure just in the building there, and financial as well, like bank networks that have networks of ATMs. I mean, we've all seen the blue screens of death from an ATM that's still running Windows XP and stuff like that. And it seems like this would be would fall into your use case of things to manage.
Yeah, for sure. No, and we're working with a few banks. We're just scratching the surface on retail. We think that's actually going to be one of our largest verticals, and surprisingly, we're actually not in production yet with any major retail player. Well, it depends on how you consider MLB, but in terms of some of the use cases that we are in place for them. But yeah, you're absolutely right. It's one of those things where, in fact, early on in my networking career at IBM, that was, I had to go around and do a number of updates for a bank, and flew around the country, with a set of disks and a hard drive, and it was unbelievable, and now, all that entire month-long process, where I was flying around from city to city, could easily be done, and we have done it from a single location, and doing all of the same functions I had to do, which was cold booting and formatting and all the things, the new OS loads and the BIOS updates and all of those things. So it is really cool to see the advancement of where we are now, and all of the cost optimization, as well as the architecture optimizations that can occur because of it. Because that's the other big piece of this, and this is adventures in DevOpsy, Kubernetes and containerization in general, right? Dramatically changed how and what the optimal state of applications is to operate in. And so, where VMs are heavy and actually, performance reductive, you can get containers on bare metal and really have a screaming application with, outstanding security. And so, yeah, the use case piece as it pertains to containers and, applications and how they're presented and architecturally to developers, that has really driven a lot of this as well.
Yeah, I remember something similar back pre Y2K. I was working in the telco space, and same thing, flew all around the country, updating a bunch of telephone systems for Y2K, carrying the floppy disk with me, upgrading them.
You said
And
Y2K.
I
That's
did, I
awesome.
did. And I'm
Yeah.
willing to bet that a significant percentage of those systems I updated for Y2K, that's probably the last time that they were updated because of how big of a
Mhm.
hassle that was.
Yeah. Well, I mean, yeah, telco is we love the space and it is changing quickly, which is a, kind of oxymoron to even say because nothing in telco changes quickly. Um, their approval process can take years. But yeah, those van rolls, and what's funny is I'd be willing to guess that a number of folks, Gen Zs, they have no idea what Y2K is. You might have to do a postscript on this podcast
Fair
just so
point.
to explain what Y2K
We're
was.
a bunch of old guys.
Yeah, man. Um, so yeah, there is the need, which is just amazing from the amount of van rolls that still have to occur, the amount of flights that still have to occur. So there's a green element to this, as well. It's like, and then we do have a green data solution. We're working like with LEED compliant certifications and lowering carbon footprint as much as possible through the new schemas that are being put in place through the Redfish, so you can monitor thermals, monitor temperature in rows and in racks and in chassis. So all the cool new sensor stuff that's coming as well. We've got a really cool green data center use case that we've built out as well. So yeah, there's the number of very pertinent problems that never got solved, but the tools are there. It's kind of like the Ring doorbell guy. It's like, hey, just if you put a few of these things together, you got a pretty cool solution. And it's kind of similar to that, except it also took open standards and everyone to play nice for it to really happen.
For sure. You mentioned that you mentioned the standards have come a long ways. Are you seeing a lot of enthusiasm? Because it's one thing, everyone's like, oh, okay, we'll support this, but then to be enthusiastic where they're like, no, we're really going to prioritize this. Are the hardware manufacturers and the OEMs really seeing the value of what you're doing here?
Absolutely. Yeah, across the board. And it's so it's a survival thing. Okay. So you have to evolve, you have to change with the times or it's not going to work out. And the way
Yeah.
we had this, I was at Red Hat prior to launching Metify. And there's a saying, if you don't like change, you're going to hate extinction. And yeah,
Sorry.
it's yeah, it's evolve. You have to evolve, right? And so the traditional big box manufacturers, the proprietary game, there's a lot of value in those boxes. There's a lot of value in those servers. However, locking it in and keeping the software discovery, provisioning, lights out management, if you will, of those servers, that was always a big revenue stream and still is. So we recognize that and there is value there. Now, the issue comes in with the proliferation of white boxes and the desire just to have rather simple compute and the cheapness of that to be able to just chuck the server and pop in a new one. That's what really drove the dynamic change that's occurring now. And that's the technology commoditization curve eventually gets every proprietary, special player, if you will, right? It's just a matter of time before someone can do it a little less expensively. So how do you, continue creating value around those platforms and around your brand? And I will say that HP and Dell and Supermicro and Lenovo and Cisco, they've done a great job doing that. These guys are they have big R&D arms, groups, and they are always innovating and trying to make things better and easier for their base. And so it's not, we're not trying to take over all hardware. This is, just where it makes sense and where customers are wanting to have a heterogeneous environment and a simpler method to access that across different vendors. So yeah, it's been a fun ride so far.
I'll bet. How long have y'all been in business?
Just 3 years now. Just 3
Okay,
years.
right on.
Yeah. So that and so I guess to wrap up, the enthusiasm from the players it's been from the start. So HP, Dell, and I think Lenovo or no, Supermicro, they were on the DMTF, the Redfish Forums board from the beginning. So it's not like the board went after this by themselves. They had the biggest guys on board with them, and the communities that are associated around Redfish are huge, and they've got a annual user conference that's growing every year, and all those things to make it happen. Same with OpenBMC, really strong following, community growth. Everyone gets that the time has come to open these things up and allow customers and folks using the hardware to manage it as kind of in the way that they want to, in the way that's most efficient for their organization.
Yeah, I think this whole conversation is a great aspect of DevOps to bring up because it's one that doesn't get a lot of attention. We talk a lot about cloud and Kubernetes and Agile and stuff like that, but there is this whole bare metal component to everything. It's just abstracted away. But now we're also seeing companies, as we mentioned earlier in the episode, they're circling back around and leaving the cloud and going back to bare metal. So I think for anyone who's starting or interested in pursuing their DevOps career, this is definitely an area that should pique your interest and open up potential opportunities for you.
Yeah. We've kind of from a programmer. So there's kind of the top-down approach to people finding out about our tool that way, where they're like, okay, so if this tool is in place, I can. We've got our back. So as a developer, you can be given a pool of servers, and a whole grouping of kickstarts or runtimes that you can load through our service catalog. And it empowers you to do your job faster, right? If you need to tear down and rebuild different environments, you can do it a hell of a lot faster with a simple tool. Instead of putting in a request to IT to have a server built that has XYZ, and then 6 months later, and that's some of the things. God, So the funny thing about DevOps, it's DevOps is in the name, right? And it's
Right.
the forgotten redheaded stepchild of DevOps. Operations, it's required to make the development happen, that's where beyond beyond all the infrastructure geeks that are actually working with the metal and working with the servers and having to somehow surface those and make them available to their developers. It can come from both sides, right? So obviously the value from an IT operations perspective is extremely evident, but it's also, and we're working with Red Hat as an example, and we're going to be going to a few Red Hat user group meetings, to make it obvious to the developers as well that if it's developer could see the value in it just as much as the guy in operations, because it does make things much faster, much easier. So we're putting the ops back in DevOps, making the ops.
Nice.
One of the very first guests I had on my Tiny DevOps podcast a couple of years ago by now the topic was that basically that a lot of people forget to pay attention to some of that ops stuff, and my guest was specifically talking about even if you're doing everything in the cloud, everything. You're never doing everything in the cloud, or almost never. I mean, there's a router in your or a switch in your office that probably needs to have the firmware updated every now and then, or bad things are going to happen.
Yeah.
And there's so much. I mean, everything virtual is built on something physical.
Yes.
As far as we know, maybe at some quantum level, maybe consciousness not. But as far as our hardware is concerned, everything virtual is built on something physical, and we forget that, and we just kind of assume that it's just magic and it works, and I don't need to worry about the BIOS update on my laptop. I don't need to worry about the firmware in my routers. I don't need to worry. And, a lot of people even forget about just what base image was my Docker container built on top of. There's so much below what we deal with that we forget about, and that's really dangerous.
It is massively dangerous, and we've seen those hits happen. It's one of those things where, well, as an example, we had a financial services company that, they were open about the issues that they were having, and they had to put off a BIOS update, and it came back to bite them and cost them millions because they simply didn't have the bandwidth to get the people in the field to take the servers down, to do the BIOS update and cycle everything. So that's the other part of this. There's a de-risking, value to bringing on a tool like ours, like Mojo Platform, that allows you to do the things you've been putting off, and allows you to get a real standardized and transparent infrastructure snapshot, if you will, that is updated in real time. So it just gives you that visibility and ease of use that's been lacking for years and years. So yeah, you're absolutely right. There's it's just somebody else's computer. The question is, how are they updating it? How are they doing the things that should be done, that need to be done to keep it secure and to keep it from breaking? And those are the two big things that we love fixing. Now, the other really fun part of this from an infrastructure perspective, so you picture, okay, there's a router somewhere. There's how do you access that? Or there's a group of servers somewhere. From an enterprise perspective, it's almost all hybrid, right? There's very few enterprises that are sort of in the Fortune 500 of any real size that are all in the cloud. And then there's the people that manage that, develop, especially the servers. It's this very dangerous thing, because from a knowledge transfer perspective, right? Knowledge management, they hold the keys to the castle. They could, if you get them upset, the danger is right there for them to do some incredible damage. And that's the other part of de-risking that we do here. It really is a knowledge management platform in the sense that it makes all of the day-to-day operational things very easy, understandable, and documented. So you can see exactly what it takes, and exactly what's in the field to do these BIOS updates, to know exactly what firmware and chip levels the different servers are on, routers, switches. So yeah, that's another big piece of this is de-risking from a knowledge management perspective. So everything isn't dependent on one guy that knows how all your servers are set up and how all the routers and how the networks are run, right? So one or two guys. So yeah, this is an important part of change management, governance, and de-risking, having your own infrastructure again.
Because it never fails. And I can say this, having been that guy is usually pretty grumpy and sometimes difficult to get info out of.
Yeah, you are proceeding at your own risk and the company's risk, right? Because you're right, that guy, with great power, they can occasionally have great egos, and then to their I guess in their corner for a minute. I mean, there's a lot that's put on those guys, and sometimes they get stretched to the edge, and um, getting a tool like this in place makes their life a hell of a lot easier. And then, yeah, as an director of IT, or an owner, and this is the thing, right? It's from any. We work well with companies. We're installed in a footprint as small as 5 servers because we're very inexpensive. So yeah, I mean, it just provides um, ease of mind and true resiliency around knowledge management when it comes to making sure that if one guy goes on vacation or quits, that you're not just dead in the water or
Yeah.
scrambling like hell.
Mhm.
Yeah.
Yeah, because in many instances, that person, no one else in the company realizes the burden that they're carrying.
Hmm. Absolutely. Well, it's that what do they call it? The hit by a bus scenario, right?
Right?
Yeah, if that dude gets hit by a bus, what about tomorrow? Who's going to keep things working? Who knows what levels things are at? Yeah.
For
And that's
sure.
the
Yeah.
other part. From an auditing perspective, it's just saves months and months of field work and digging to assist with insurance, banks, HIPAA, healthcare. Across the board, there's just a number of um, sectors business sectors that require very specific auditing to be put in place. And we have a reporting tool that's built into Mojo platform as well that makes it really, really simple. So kind of covered a lot of bases with the tool when Ian kind of dealt with it all, and then with a ton of feedback too from these enterprise customers to build sort of the dream tool for them. What do they need? And the best part about being um, REST based and sort of modern is that as the new requisites, and we help guide the direction of that as well, for the specifications get brought into the DMTF or OpenBMC. As soon as those new schemas are ratified, and that it becomes available for and published through the DMTF, or even before, sometimes we'll do custom work. We can bring that into the tool and make it available to everybody. So it's a really cool thing, because it's, as far as refactoring the code, there's very little that has to happen. It's just pointing to a new um, schema within the API itself. So
Oh, wow.
yeah, so you can just
That's super
onboard
cool.
onboard new functionality, onboard new features really quickly. Um, yeah, and then they're getting down into the DCIM space as well, like I said, around thermals and heat and everything else. So it's really just keeps on expanding. The use cases keep on expanding, and then the power of open, having all that R&D kind of being handled by your customers, by the communities, by all the people feeding into these projects, makes life, it is, you can't compete with that. You can't compete with the literally billions of dollars essentially being poured in man hours and development from an R&D perspective, having those open standards in place.
Wow. This has just been eye opening for me. Like, having done data center work in the past, now to have all of those things that I hated about working in a data center just be wrapped up into a single tool to give you visibility into like the status of the hardware and what's the firmware level, and just that whole visibility. This takes a huge burden off of the consideration and the workload of thinking about or pursuing a bare metal infrastructure.
Mhm.
Thanks. Yeah, that's a goal. I mean, no more having to go up and hit F5 and do all that low level madness, or F12, right? Get the BIOS going. Yeah, we got it all built into the tool and automated it. So yeah, it's a big step. It's exciting. And the best part is when the customers see it and they recognize behind their own firewall, oh wow, I see exactly what this is going to save us. That moment, it just never gets old, because the reactions are um, just awesome. To see, and when it gets implemented, and you see it in working for them and doing all the things that they wanted to do. It's just a very fulfilling, very rewarding part of having a startup, for sure, having a software product.
Yeah, that's just mind blowing. So you mentioned a couple times your service catalog. What and I would imagine you have like in your service catalog, like here's the latest firmware and BIOS updates for these different things. But then you also mentioned OS management as well from a developer's perspective. So what does your software catalog offer at that higher level for users of the infrastructure?
Yeah, so the service catalog has the more complex builds that would come after sort of a standard provisioning and runtime is put in place, if you will. So, and that's you can do that either for us through templating, YAML, or you can do it via GUI. So we have both, right? You can do it either in sort of a mass gold image, if you will, gold build, and really powered by Ansible for the most part. But
Okay.
we work with any of them. Um, and then I'm sorry, the question, the second part of that question was
Just like types of things that are in the service catalog, from a
yeah,
developer
sorry,
perspective.
gotcha, yes. And then so that's the so say OpenShift cluster on ESXi, something like that,
Yeah.
right? So we've got that dropped in, you built out in the catalog, whatever your environment requires. So in virtualization, we're great. We work, we're a VMware partner. We work with Tanzu, ESXi. That's a very common build for us. But again, we're beneath that, so we're good with that. If a virtualized environment is what is optimal for your applications and for that particular use case, great, no problem. So yeah, it's the upstack associated builds themselves that we can add service catalog elements for.
Gotcha. And you said it's all primarily using Ansible, so literally anything you can build with Ansible can become a product in the service catalog.
That's right. Yep.
Wow. Holy cow.
Yeah, man. Fun times indeed.
I remember. Here's a little anecdote from my time in the data center.
Back in the day.
Yeah, back in the day, I was so proud of myself that I went on eBay and bought a Portmaster 2. Either of you know what that is?
Wow.
Nope.
No.
So this was 2005 or so. Portmaster 2s were probably in their heyday in 1995. The Portmaster 3, I remember using when I was at my first real job out of high school. It was a dial-up ISP. The Portmaster 3 was a Lucent piece of equipment. I think it was Lucent, or maybe it was bought by Lucent. But you'd plug a T1 into it, and it would provide dial-up access, 56K dial-up access on that provision T1. Portmaster 3 predated that, so it was a expandable box with I think up to 30 RS-232 ports on it.
Oh,
wow.
Nice.
Or you could get an ISDN module, but that's not what I cared about. So I bought this Portmaster 2. I think I had 10 ports, the one I bought on eBay, and that was my KVM switch for these servers sitting a four-hour drive away.
Wow.
So I set up Linux on the serial console, so I could do almost everything I needed.
Yeah.
With this. Now it wasn't really managed. It was just a serial console.
Wow.
And some of our BIOSes supported serial consoles on the from the boot screen. That was the best. We had some old servers that didn't have that. So as long as Linux would boot to the kernel, we were golden. But whenever Linux failed to boot for some reason, corrupted disk or a bad upgrade or whatever, we had to hop in the car, drive 3 to 4 hours to the data center and get that thing running again.
Man, that's a setup. That's a hell of a way to do it. Yeah.
We had somebody at the company trying to convince us to set up an IP KVM, which would admittedly be better because then you have direct access to the video signal and the keyboard. So anything you can do with a keyboard monitor, you can do. So it gives you a little bit more. But I was like, that was I don't remember several $100 or $1,000 at the time. Yeah. Versus this like $20 eBay purchase that gave us like 98.6% of the functionality.
At
What's funny is I
9600
guarantee.
baud.
Yeah.
So what percentage?
Oh,
of
we
people,
had 115K, man. I mean, it was plugged into something fast. Yeah.
Screamer. Well, so what percentage of people do you think when you're saying KVM? I'm betting they're thinking they're thinking
That's right.
virtualization.
Yeah, probably
But
worth clarifying
I
the
meant
definition of KVM.
is it keyboard video? What does it stand for? Keyboard video
keyboard,
monitor.
Keyboard,
video,
I don't
video,
remember if that's.
mouse.
Yes, that's what it was.
yes,
Yeah.
keyboard, video, mouse.
So
Boom. Look at that.
people use those, especially gamers will use those if you want to switch between two. You have a Mac and a Windows PC or something. You want to switch between the same monitor. That's what I'm talking about for anybody listening. I'm talking about that switch, so you can have multiple computers hooked up to a single keyboard, monitor, and mouse.
Yeah.
So I had these 10 serial ports connected to my 10 servers, whatever number of servers there were, and I could telnet into that portmaster 2, and from there I could connect to any one of those 10 or so servers.
Very cool. That's a very wicked setup for the day.
I love that adjective for it.
Yeah. Very cool.
Right on. So we're approaching an hour here. Is there anything else that we should talk about? We should talk about the name Mojo. That's a super cool name. Where did that come from?
So Metify is a portmanteau of metal simplified, and Mojo platform was like magic, So when it came to and this kind of goes back to sort of that Mojo magic thing. It just get your mojo back, Austin Powers
Right.
can't help but be a fan there. It just kind of goes into that, right? The magic of doing metal very easily behind your own firewall, DIY, save a bunch of money. It's like magic. So yeah, Mojo is kind of an amalgamation of all those things, if you will.
When I asked that question, I was hoping that it was going to lead to an Austin Powers reference. So
It
did not
did.
disappoint.
Yeah, man. Come on. Austin Powers. Now that guy needs to make a comeback. The world needs Austin.
Right? Yeah.
Yeah,
For
baby.
sure.
Yeah.
Simpler times. Yeah.
Cool. Anything else that we should talk about, or you'd like to share with us about Metify or getting your mojo back?
Yeah, man. No, I think that pretty much covers. We covered a lot of bases. It's an amazing tool, and like I said, if you have from 5 to 500,000, 5 million servers.
Million.
You got to do the pinky thing.
That's right. Servers.
Freaking laser beams attached to their head.
It can do an amazing thing, and we can connect to those lasers and remotely shoot those for you. So got you covered on every front.
You can
check it out.
update the firmware on the lasers mounted to your shark heads using the
That's-
Mojo platform.
That's right. Dr. Evil is actually a big customer, so we
Nice.
appreciate him and his team.
Right on. So let's move on to picks. Jonathan, I'm putting you on the spot. Have you got a pick for us?
I do. I'm gonna do some shameless self promotion today.
Nice.
And I'm gonna pick my new podcast. We're about to do episode number 20. It's called Cup of Go. It's all about what's new this week in the Golang community. And we've got our first corporate sponsor recently, so that's an exciting milestone. So we're doing really well. We have swag. If you want a cute little coffee cup or a sticker or a wireless charger with our new logo on it, check it out. Go to cupago.dev. You can find all the episodes there and find us on social media. We have an active Slack channel on the Gopher Slack too, so that's a fun place to hang out. So that's my pick for the week.
Right on. Yeah, you've been cranking out the content there. I keep seeing new episodes coming out all the time. So good job on that.
Yep. Thanks.
All right, Mike, putting you on the spot next. What have you got for us for a pick?
Wow. So I'm a physics geek, so I'll give you one of many cool physics topics that I love. Check out John Stuart Bell. He was the guy who actually created Bell's inequality, which helped prove non-local influence, instant non-local influence, and sort of did manage to prove Einstein wrong about one thing. So if you want to see the guy who proved Einstein wrong about a big thing, namely
Spooky action at a distance, right?
relativity, and the idea that everything has to be there has to be a local influence. He's the guy to check out, John Stuart Bell. So he's very cool physics guy who essentially and the Nobel Prize in Physics actually went to the guys that proved his inequality. So the three guys last year who actually received the Nobel Prize in Physics. But yeah, John Stuart Bell, man, the guy's amazing, and he didn't seem to get his props. Nobody knows who he is, but he's incredible. He was
right on. That's cool. I'll definitely check that out because I'm a big physics geek myself. Going all the way back to my first job out of high school, I joined the Navy and became a nuclear engineer. So just have always been fascinated by physics and all the different aspects of it.
Cool.
So my pick, because you mentioned guitars earlier and you've got the guitars in the background, I'm going to show off my Schecter guitar here, and it's got the Sustainiac pickup on it. So if you play guitar and you've never had a Sustainiac pickup, it's been the most fun I've had in decades playing guitar. And so the Sustainiac does kind of what the name implies. You can hit a note, and then it just continues to use the harmonics to keep that note ringing out forever. So you can play like the blues and the like Zakk Wylde, Ozzy Osbourne type stuff, where they just hit those squealing harmonics and just let them scream on forever and get that simulated feedback without having to crank your amp up to 11, although you're probably going to want to do that anyway. So Sustainiac pickups. It's my pick for the week.
Awesome.
I haven't had any pickups since I got married.
Cymbal crack.
Right? And that's a good thing.
Are you gonna play it? Are you gonna play it for us, Will? I see you holding the guitar there.
We can. It's not plugged in, but put me on a spot here. We'll do a little Slayer riff for you.
Oh yeah.
Awesome.
Next time you got to plug that puppy in and give us some distortion and make that thing come alive with Sustainiac happening.
Right, because that clearly did not do Slayer any justice, but that's what we'll go with for this episode.
We're holding you to it next time, Will.
I could hear the tight chording. It was fun. All right.
Cool. Well, thank you everyone for listening, and we will see y'all in the next episode.